Welcome, welcome. This is Unit 1, Section 6, Absolute Value Functions. So this is a toolkit function. Remember, FCN stands for function. So that's a toolkit function, and it's the one that looks like this. So this section of it is y equals x, and this section of it is y equals negative x. Here's this definition. We can think of this like a distance if we wanted to. So the absolute value of x, no matter what we put into x, we'll always get the positive version. So if we put 4 in, of course we'll get 4. If we put negative 4 in, we'll get 4. So that's what that looks like. So we can think of this like a distance. The absolute value would give me the distance from 0. Resistance of a resistor. I will give you a second to read this. Okay. So our resistor is rated at 680 ohms, and it's acceptable for it to be within 5%. Another way to say this is 680 ohms within 5%. That's another way to say that they're equal. So if you see that in the textbook, that's what that means. So it wants us to use the absolute value function to express the range of possible values of the actual resistance. So our input here is going to be, if we say R is the resistor we're testing, so the one that we're testing to see if it is within range, if we subtract the 680 ohms it is supposed to be, this needs to be less than or equal to that 5%. Okay, so if you wanted to observe what's going on here, so 680 is ideal, right? So what this is saying is that you can take away, these are brackets, is that you could take away or you could add 34 ohms and it would still be acceptable. Anything outside of here and it will get rejected for safety or quality reasons or whatever. Now graphing an absolute value function. So our absolute value function is y equals f of x, absolute value of x. So let's examine things here. This is what it looks like when we have something shifting horizontally. So horizontal shift, a sideways shift. This is what it looks like when we have a vertical stretch. Oh, I'm sorry, vertical stretch. the up and down stretch. Now if we did one more thing, plus 4. Now this brings it up by 4 units. Remember? Because it goes with the sign. This one would be 3 units right. So that's in the positive direction because it's opposite of this middle sign. So writing an equation for an absolute value function. So we're going to use this graph to write an equation. So let's make note of a couple of things. First, let's focus on what happened on the outside because it looks like it was moved both up and down. So this way and this way. So it looks like it was moved down because remember, it's supposed to be here. It's supposed to look like this. So it looks like it was moved down 2 units. And it looks like it was moved over 3 units. To the right 3 units. Remember, this up and down is in Y, and this side to side is in X. So I know I'm going to have something, so our parent function, the toolkit function, I know I'm going to subtract 2 from it, right? And that's because it goes down 2 units. And then I also know that it's going to go right 3 units. So since it's the opposite sign and I'm moving it in the positive direction, it will be negative 3 minus 2. And now let's think about, we know it's going to be multiplied by something, right? Because it's been squished. And we'll put that, let's go ahead and write it in this form. Here, we'll leave that there. And then we know it's going to be in this form. So that gives me a x minus 3 minus 2. And I am going to take a point from this. So I'm going to take this point, 4, 0. And I'm going to plug that in and solve for a. So this is our x. This is our f of x, which is equal to y. And remember, that's this whole thing, which is equal to y. So it's going to be a, our x is 4 minus 3 minus 2 is equal to, remember our y is 0. So it's going to be a, 4 minus 3 is 1, I'm not going to write it, minus 2 equals 0. The absolute value of a is going to equal 2. And I'm going to make it positive 2. And that is because if it were negative 2, it would flip over the axis. So it'd be facing upside down. Now, one of the things about vertical stretches and horizontal compressions is you can kind of interchange. Here you can interchange them. So we can either have 2 x minus 3 minus 2, and that is y equals, or we can have y equals 2 x minus 3 minus 2. They would both give you the same thing. Okay, now we need to write the absolute value equation for a function that is horizontally shifted left 2 units. So that means we're going to have something along the lines of it's changing in the x's because it's horizontal, and it's shifting left, which is towards the negatives. So that means we're going to add it. So it's going to be x plus 2. It's vertically flipped. So vertically means that instead of this, we now have this. So it flipped vertically. So here that means we're going to multiply by -1, the whole thing by -1. And it was vertically shifted up 3 units. That's a change in y. So up 3 units, since it's a change in y, it goes with the sign. So it's going to be plus 3 units. So we will have something that looks like negative f negative f x plus 2 plus 3. So it's going to be negative x plus 2 plus 3. And that's what we have. So solving an absolute value equation. So the way absolute value equations work, since you can have positive and you can have negative, is you actually have 2. So let's say I had x minus 3 is equal to 7. Then I would have x minus 3 is equal to 7, or x minus 3 is equal to negative 7. And I could solve for those. But notice, this is one important thing to point out here. If you have an absolute value equal to a negative, this is no-no. If you remember the graph, it can't be negative. So an absolute value cannot be negative. Now keep in mind that that an equation with an absolute value in it can be negative, but the absolute value itself cannot be negative. So anything with an absolute value strictly cannot be negative. So here we are going to find where f of x is equal to 0. Now, since we have something on the outside of it, negative 7, we're going to move it over because we want the absolute value bars alone. So we'll get 4x plus 1 equals 7. And you know what? That's positive, so we're good to go. We can keep moving. Now we're going to get 4x plus 1 equals 7, or 4x plus 1 equals negative 7. And we set it negative because remember, a negative value inside an absolute value function will give us the same answer as a positive value. So we have 4x equals 6, or 4x equals negative 8. And then we have x equals 6 divided by 4, which is 3 divided by 2, or x equals negative 2. And you can double check. 4 times 3 divided by 2 plus 1 minus 7 gives us 2 times 3 plus 1 minus 7, which is 7 minus 7 equals 0. That's good. 4 times negative 2 plus 1 minus 7, and that equals negative 8 plus 1 minus 7, and this equals plus 1. This equals negative 7 minus 7, so it's going to equal 7 minus 7, which equals 0, which is good, because remember we wanted it to equal 0. So these are our values. Okay, solving an absolute value equation. So now we're going to solve this. We get a pen. So the first thing we're going to do is we can take what's on the outside and we can move everything over because we need the absolute value alone. So that we get 4x minus 2 equals 1 minus 2, which is negative 1. And for those of you that noticed something, that's totally fine, but I'm going to keep going. We're going to divide by 4. Now notice, now that I have the absolute values alone, I have a negative. That's not good. So there's no solution. And that's what no solution looks like. So I need to find where this intersects the horizontal and vertical axis. So in order to intersect the horizontal axis, I'm going to need my form x0. To intersect the vertical, I need 0, y. So that means I need to find out all these values where it's 0. So let's start with y. Equals 0. And that gives us negative x plus 2 equals negative 3. Dividing by negative 1, we get x plus 2 equals 3. So we get x plus 2 equals 3, or x plus 2 equals negative 3, which gives us x equals 3 minus 2 is 1. This is minus 5. So then we know that 1, 0 and negative 5, 0 are where it intersects the x-axis, because we made our y 0. We started here. Now let's make our x 0. That gives us negative . So we get negative 2 plus 3 equals y. 1 equals y. So we get 0, 1 as our point. So it looks like it will cross at 1, 0, negative 5, 0, and then again at 1, 0. So that's kind of what that would look like. So now solving absolute value inequalities. These are ones that can be thought also like on a number line. This is the absolute value of x, this is the absolute value of x. Now the way we're going to go about solving these is there we go. So let's say this. What you're going to go about doing, and I'll go over it here and I'm sure I'll go over it again later in the video, is you're going to solve this. So it's going to be x minus 4 less than or equal to 6 divided by 2 is 3. So now we're going to make one negative, like this. Okay. So plus 4. So now we have 1 x 7. And now you must check it in case your signs are wrong. So how you do that is you divide it into an interval. So you would have 1 here and 7. You're going to choose your points. And you will choose points in between them. I'll do 10 here, I'll do 5, and I'll do -1. So now I'm going to test all these points on my line. So 2 up at the top, say my x is -1. -1 minus 4. What does that equal? 2, -5, that equals 2 times 5, that's 10. Is that less than or equal to 6? No, it's not. Now let's test 1 to see if we need to include it. We're good here, so we can include it. Now what about 5? Is that less than or equal to 6? Yes, it is. So that means everything in this interval is good. So now let's say we have the 7. It's good, so we include 7. Now 10. What are we doing? All right, 10 minus 4. And that's not true, so we don't include these. Okay, so this is the answer. Also, it would be 1, 7. In the interval notation is interval notation. Either one of those. So that's the process. Now we're going to try this one. So remember, okay, so that gives us 1, x, and there you go, 9. So x is less than 9 but greater than 1. going to make my interval. That should be correct, but let's just super make sure. 0 to 10. Okay, so the absolute value of x minus 0, the absolute value of 0 minus 5 is equal to 5. And is that less than 4? No, it is not. So we do not include these guys. What about 1? 1 minus 5. That is equal to negative 4. Is that less than 4? No, it's not. We will not include the endpoint. What about 2 minus 5? It's equal to negative 3, which is equal to 3. Is that less than 4? Yes, it is. We'll include these guys. And now we're going to test 9. 9 minus 5 is equal to 4. Is equal to 4. Is that less than 4? No, it's not. We're not going to include 9. What about 10? It's not. So we're good. So it's going to be 1, 9. All right. We're going to go with this one. X plus 2. Less than or equal to 6. So we're going to go this route. Subtracting 2 from both sides. Oh, switch those up, huh? Creating a new number line, guys. Negative 8, 4, this can be 1, this can be 5, this can be negative 10. Okay, so negative 10 plus 2. That equals negative 8, which equals 8. Is that less than or equal to 6? No, it's not. So what about negative 8? That is equal to negative 6. This is true. So we would include that. Now what about 1 plus 2? Is that less than or equal to 6? Well, we get 3 is less than or equal to 6. That's true. Okay, now we have 4 plus 2 equals 6 6. Less than or equal to 6. That's true. We're going to include that endpoint. So I assume the other one's not going to work out, but you know, we'll just go ahead and do it. Yeah. There we go. And that gives us negative 8, 4. And that wraps it up for section 6, the absolute value function. I will see you guys in the next one.